Last time, we explored the robust simplicity of Mikhail Kalashnikov's AK-47, a weapon that armed revolutionaries and armies across the globe. Today, we turn to its Western counterpart, a rifle born from innovation and controversy, which would ultimately define modern infantry combat for decades, Eugene Stoner's AR-15. This lightweight, high-velocity design promised a revolution in firepower, but its early service was plagued by a dark secret. How did a rifle that initially failed its soldiers become an enduring symbol of military might and a cultural icon? In the wake of World War II, military strategists and firearms designers across the globe grappled with the future of infantry combat. The devastating effectiveness of German assault rifles like the STG-44 had highlighted the need for lighter, faster-firing weapons that could deliver controlled automatic fire at intermediate ranges. The United States Army, in particular, was keen to equip its soldiers with a next-generation rifle, moving beyond the traditional heavy battle rifles of previous conflicts. While European powers debated intermediate cartridges, NATO standardization efforts in the early 1950s pushed for the adoption of the powerful 7.62 by 51 mm round. This led the U.S. Army to select the M16 rifle, a traditional wood and steel battle rifle, in 1957. However, a small, innovative aerospace company, Armalite, was already exploring a radical new direction in small arms design, one that challenged conventional wisdom. At the heart of Armalite's revolutionary approach was Eugene Stoner, a brilliant self-taught firearms designer. Stoner envisioned a rifle built with lightweight, advanced materials, drawing inspiration from the aerospace industry. His philosophy emphasized modularity, ease of manufacture, and reduced weight, moving away from the heavy, complex designs that had dominated military arsenals for centuries. Stoner's initial design, the AR-10, emerged in the mid-1950s, chambered for the 7.62 by 51 mm NATO cartridge. It was a marvel of engineering for its time, incorporating aircraft-grade aluminum forgings for the receiver and pioneering the use of composite plastics for its stock and handguards. The AR-10 also featured Stoner's innovative direct impingement gas system, which promised a lighter, more accurate weapon with reduced recoil. Despite its groundbreaking features, the AR-10 ultimately lost out to the M16 during the U.S. Army's rifle trials in the late 1950s. The military establishment, rooted in tradition, viewed its lightweight construction and direct impingement system with skepticism. Though a few countries like Sudan and Portugal acquired limited numbers, Stoner's revolutionary design was initially deemed too unconventional for widespread adoption by a major power. However, the U.S. Continental Army Command, CONARC, still harbored interest in a lightweight, smaller caliber weapon for certain roles. General Willard G. Wyman's specific request for a new rifle weighing less than 6 pounds, capable of selective fire, spurred Stoner's team at Armalite to scale down the AR-10. This led to the birth of the AR-15, chambered for the then novel .223 Remington cartridge, later standardized as 5.56 by 45 mm. The AR-15 retained the AR-10's core design principles: a direct impingement gas system, a modular upper and lower receiver, and extensive use of lightweight materials. Its inline stock design, placing the recoil spring directly behind the bolt, significantly reduced muzzle climb, making the rifle remarkably controllable during automatic fire. This emphasis on lightweight and high velocity was intended to allow soldiers to carry more ammunition and achieve greater hit probability. Facing financial difficulties, Armalite made a pivotal decision in 1959, selling the manufacturing rights for both the AR-10 and AR-15 to Colt's Patent Firearms Manufacturing Company. This transfer was crucial for the rifle's future, as Colt possessed the extensive manufacturing infrastructure and established military contracts necessary for large-scale production. With Colt's backing, the AR-15 was poised for greater exposure and potential adoption. One of the AR-15's earliest and most influential proponents was General Curtis LeMay, then Chief of Staff of the U.S. Air Force. Impressed by the rifle's performance during a demonstration, LeMay quickly championed its adoption for air-base security forces. His advocacy led to the U.S. Air Force placing initial orders for 8,500 AR-15s, marking the weapon's first significant procurement by a major branch of the U.S. military. As U.S. involvement in Vietnam escalated in the early 1960s, Secretary of Defense Robert McNamara sought to standardize infantry weapons across all services. He personally ordered comparative trials between the M14, the AR-15, and captured AK-47s. The AR-15's lightweight design, manageable recoil, and ability for soldiers to carry significantly more ammunition proved highly attractive amidst the logistical challenges of jungle warfare. Despite persistent resistance from the U.S. Army, which favored the M14, McNamara's direct intervention proved decisive. In 1964, the AR-15 was officially adopted by the U.S. Air Force as the M16 rifle. Concurrently, the U.S. Army designated it the M16E1 for limited issue, primarily to Special Forces and airborne units deploying to the demanding combat environment of South Vietnam, signaling a major shift in military doctrine. Initial reports from soldiers in Vietnam were largely enthusiastic. Troops praised the M16's light weight, which reduced fatigue during long patrols, and its low recoil, allowing for quicker follow-up shots. The ability to carry more 5.56mm ammunition compared to 7.62mm rounds was also a significant advantage. The rifle's sleek, modern aesthetics even offered a psychological boost, portraying an image of advanced American firepower. However, the seeds of future disaster were sown early in the M16's mass production. The original AR-15 had been designed and tested with IMR 4475 extruded smokeless powder. For reasons of logistics and cost, the U.S. Army Ordnance Corps inexplicably switched to WC-846 ball powder for the 5.56mm ammunition issued to troops. This ball powder burned significantly dirtier and at higher pressures, leading to excessive fouling within the rifle's direct impingement gas system. Adding to the problem, the initial production M16S and XM16E1S lacked chrome plating in the barrel bore and chamber, a cost-cutting measure not present in Eugene Stoner's original AR-10 design. Chrome plating significantly reduces corrosion and friction, making cleaning easier and enhancing durability in harsh conditions. Without this vital protective layer, the corrosive byproducts of the WC-846 ball powder quickly attacked the rifle's internal components, exacerbating reliability issues. Compounding these design flaws was a dangerous misconception propagated by inadequate training in early promotional materials, the myth of the self-cleaning rifle. Soldiers were often told the M16 required minimal maintenance due to its advanced engineering, and in many cases, cleaning kits were not even issued. This neglect, coupled with the dirty burning powder and unplated components, created a recipe for catastrophic failures in the unforgiving environment of Vietnam. The reliability issues quickly escalated into a full-blown crisis on the battlefields. M16s frequently suffered from jams, failures to extract spent casings, and broken parts, often at the most critical moments during firefights. Heartbreaking accounts emerged of U.S. soldiers being killed or seriously wounded while desperately trying to clear their malfunctioning rifles in the face of enemy fire. This led to a profound and dangerous distrust in their primary weapon. The mounting casualties and widespread complaints from the field eventually forced a public reckoning. In 1967, a highly publicized congressional investigation was launched, scrutinizing the M16's reliability problems. Testimony from soldiers, unit commanders, and technical experts laid bare the systemic failures in procurement, ammunition selection, and training that had turned a promising weapon into a liability. The inquiry demanded immediate and drastic corrective actions. The first major response to the crisis was the rapid introduction of the M16A1. This updated variant addressed the most critical issues by reintroducing a chrome-lined chamber and bore, significantly mitigating fouling and corrosion. It also controversially included a forward assist mechanism, a plunger on the receiver allowing soldiers to manually seat a bolt that had failed to close, an addition Eugene Stoner himself reportedly disliked. Beyond the physical modifications, a comprehensive effort was launched to restore soldier confidence and ensure proper weapon care. Cleaning kits, containing rods, brushes, and solvent, were finally issued with every M16A1, a crucial step that had been overlooked before. Furthermore, extensive training on proper maintenance became mandatory, with revised field manuals emphasizing the importance of regular cleaning and dispelling the self-cleaning myth for good. With the M16A1 and these critical logistical and training improvements, the rifle's reliability dramatically increased. Soldiers in Vietnam began to regain trust in their weapon, recognizing its inherent advantages when properly maintained. The M16 finally lived up to its potential, becoming an effective and lethal tool in the unique combat environment of Southeast Asia, proving the tactical value of its lightweight and high rate of fire. Following the Vietnam War, the M16 platform continued its evolution to meet changing military doctrines and international standards. In the early 1980s, the M16A2 was developed, primarily to accommodate the new NATO standard 5.56 by 45 mm SS-109 cartridge, which featured a heavier, more aerodynamic bullet. This redesign also incorporated a thicker barrel for sustained fire, improved adjustable rear sights, and replaced the full automatic option with a 3-round burst mode. The 1990s brought further advancements with the M16A3 and M16A4, which fully embraced modularity. The most significant innovation was the introduction of the flat-top upper receiver, featuring an integral Picatinny rail system. This allowed soldiers to easily mount a wide array of optics, night vision devices, tactical lights, and other accessories, dramatically enhancing the rifle's versatility and adaptability for diverse mission profiles. Concurrently, a shorter, more compact variant, the M4 carbine, emerged as a highly popular choice. Initially adopted by Special Operations Forces in the 1990s, its collapsible stock and shorter barrel offered enhanced maneuverability in close quarters, urban combat, and vehicle operations. The M4 eventually became the standard issue weapon for a large portion of the U.S. military, further solidifying the AR-15 platform's dominance. Beyond the United States, the M16 and its numerous variants achieved global recognition and adoption. Over 80 countries worldwide integrated the 5.56mm AR-15 platform into their arsenals, from NATO allies like Canada and the United Kingdom to nations in the Middle East and Asia. Its modularity, consistent performance, and the availability of compatible accessories made it a highly attractive and practical choice for diverse operational needs globally. Eugene Stoner's design pioneered a paradigm shift in firearms manufacturing, moving away from heavy steel and wood towards lightweight alloys and composite materials. The direct impingement gas system, despite its early troubles, proved to be an efficient and elegant solution, influencing countless subsequent designs. Most significantly, the modularity of the AR-15 platform set a new standard for military firearms, enabling rapid customization and adaptability in the field. From the steamy jungles of Vietnam to the dusty deserts of Iraq and Afghanistan, the M16/AR-15 platform has served as the primary service rifle for the U.S. military for over half a century. It has undergone continuous evolution and adaptation, reflecting the changing doctrines and technological advancements of warfare. Its distinct silhouette is now instantly recognizable, synonymous with the modern Western soldier and a symbol of military power. The AR-15's journey from a revolutionary concept to a problematic weapon, and then to a reliable workhorse, is a testament to the complex interplay of innovation, military necessity, and human adaptation. It has transcended its military role to become a potent cultural symbol, representing both freedom and controversy in civilian contexts worldwide. Its story is deeply etched into the annals of modern military history and gun culture. Eugene Stoner's AR-15 fundamentally reshaped infantry combat and weapon design, demonstrating that even a troubled beginning can lead to an enduring legacy. Its adaptability and influence continue to resonate across the globe, from battlefields to civilian ranges. But as militaries face increasingly complex threats, a new generation of weapons is emerging, designed for the covert world of elite operators. Next, we will delve into the specialized tools that arm the silent professionals of modern special forces.